Okay, so we want to move on from using beam elements to using solid elements. Of course, we know when we are using beam element, I was using one-dimensional element. And everything in life is 3D. Everything in life is 3D. So if I go back here to one of the questions that we have done, and let me share my screen. And I take you back to the very first example that we have done. And in this example, we had two cylinders that were connected together, A, B, C, was fixed at A and was set to a displacement of 0.002 inches at C. And we learned that when this is subject to this 1,000 pound force, that this was going to hit the wall. Section 1 had a radius R1 of 0.178412 inches, and section 2 had a radius R2 of 0.29851 inches. And again, this is how we modeled it using beams. And keep in mind that a beam element is 1D element. And all what we needed were lines. But now today, I want to go to the next step, is using 3D geometry, which is now most of your parts, you're gonna create the CAD in CATIA or Creo or SolidWorks, and you already have a 3D geometry. And if we have the computer power, we can, within this geometry, fill in a mesh. So using 3D geometry, we can use solid elements for 3D modeling. And I want to say that this does not necessarily mean that this is a better analysis than using the 1D element. As a matter of fact, in some cases, we can have a better representation of the behavior of a structure using this powerful 1D element. I'll give you example. Some of your colleagues working on the formula hybrid, for example, car, when they are trying to model the frame of their car, they find that they get much more reasonable results modeling that frame using beam elements compared than what they would get if they try to use solid model using these very thin tubes that they're using for the frame of their car. So really, you want to know all the tools that are available for you and make sure you are using the right tool for the right problem. But definitely, for so many complex geometry, we can fit a 3D mesh using solid elements and get some accurate results for these parts that are primarily made of solids. They're not like linear parts, cylindrical part like the one we use for trusses, for example, or for skeletal structures. So it would be definitely preferred that we use a 3D model. So we would like to start learning about how to use this solid element with a 3D geometry or a 3D CAD. And in order to make sure we're not just learning to use the tool, ANSYS Workbench in this case, but rather making sure we understand or correlate a little bit of what we're doing to what we're doing as far as theory, I'm gonna go over intentionally over the same problems that we've done using beam elements, but this time we're gonna be doing them using solid elements. And this is why you're gonna find that your first homework number 9, is the same as homework number 5, is the same as homework number 6. When you did it for homework 5, you did it using finite element method and matrices. In homework 6, you did it using beam elements, and in homework 9, you're gonna do it using solid elements. So the first step when we're gonna use solid element would be to create a 3D geometry or a 3D CAD. And our 3D geometry can be, of course, imported. But in this class, I would like to focus on using design modeler. So we're going to continue to use design modeler. And remember, in design modeler, we have primarily 2 modes. We are in modeling or using sketcher. So we can create sketches and do modeling. And in order to create a 3D geometry, I would like to mention that we're going to be using extrude and revolve. So these are the 2 functions that we're going to be using to create this geometry in this class. All right. With that being said, I would like to go to create this geometry in design modeler as a 3D model. So if you look at this, simply, I can look at either revolving or extruding. Revolving or extruding. I can simply create a profile and revolve it about this axis, or I can create the section and simply have 2 parts that are extruded. So for today, let's try to extrude. And I know most of you have already quite some experience because you use other similar CAD packages. So let me get here to, so we're gonna start a fresh static structure analysis. And I'm gonna save this as first solid example. And I'm going to go to design modeler. So I'm going to say new design modeler geometry. I'm just doing this step because I'm magnifying my screen so you can better see it. So I have to move my toolbars to display more of my screen, but you typically don't have to worry about this. All right. So I would like to start with a sketch that we can extrude. And I want to extrude along the x-axis. I want to extrude along the x-axis. So I'm going to create my section in the YZ plane. So I do not want to define a new plane, so I'm just going to delete this for now. So I want to start by creating a sketch in the YZ plane. So I can come here and insert a sketch. I can also go to my menu. You can see here this blue icon that I'm pointing my mouse on. It says YZ plane, and if I click this icon, it's creating a sketch for me in the YZ plane. And I can look at the one that I am creating. So I can click here, this icon, and now I'm looking at the YZ plane. And simply, I just want to use the sketching tool. So I have here sketching and modeling. So I'm using the sketching toolbox, and I'm gonna go to draw, and I'm gonna draw a circle. So let me go down, scroll down here, circle. And I wanna come and make sure, you see there are letters that appear, there is a C, there is a P. I wanna make sure that my center is right at the origin. So I wanna use a point constraint. So when this P shows up, it means I have a point constraint, constraining into the origin. I'm gonna click my left mouse button and pull to create my circle. I look at the ruler and I'm working in meters. So this is gonna be a huge section. So I'm gonna make it as small as possible. Yeah, I think I have to change my scale. So I'm gonna just leave this for now. And I'm just gonna go to my units and make sure I'm using inches. And definitely I'm not gonna like this circle. We wanna change in inches. This is 2000 inches. If I go to dimensions for my sketch, D1, you see this is 2000. I'm gonna bring it to 20 just to fix it a little bit. I'm gonna scale it down. Just want to make sure I can see my dimensions. I'm gonna go to under dimension. I'm gonna go to move to be able to move my dimension. So I'm move it closer. I'm gonna zoom in here, move it again, zoom more. Now I'm gonna change my radius to 0.178412 inches. And I'm gonna move my dimension closer to the section. Move it further. So we have this 0.17841 inch for the dimension, and this is my section. I am gonna generate this section. I'm gonna click generate. And I have my first section. If I go to modeling and go to 3D, you see here, this is my section. The next step is I'm gonna go to extrude. And when I use the extrude function, it's gonna ask me for a geometry. And by default here is taking my sketch 1, which is fine. And I'm gonna extrude direction is normal. And I wanna extrude this 10 inches. So I'm gonna come here and put 10 inches. So it is showing me where it's gonna extrude my section. If I like it, I'm gonna say generate. And here comes my first part. Next, we wanna create another extrude. See here, I have one part and one body. One part and one body. I use add material. I wanna create another section on this plane. So I can simply create a plane here. So I can come and insert a plane. So I can come and say create new plane, and I'm gonna create it from a face, and I'm gonna select, come here and select this face and say apply. So now I have generate, I have a new plane here, and on this plane, I'm gonna sketch, use again the sketching tool. So if you missed it the first time, you can follow with me again. I'm gonna create a sketch, and this sketch is on plane 5, the one I just created. And again, I want to simply define a circle. So I go to circle. I want to make sure I can look at my plane where I'm sketching. Okay, here it comes. So I want to make sure I see the P. Here's the P, and I'm doing a circle. And now this should have a diameter. So I'm gonna go to, I wanna define a radius. I go to dimensions, select the radius, and I come here, pick my circle, put my R1, and this radius should now be 0.29851, enter. I edit my radius, so this is my second part, the section for my second part. If we like it, we're gonna say generate. I'm gonna go back to modeling, look at the 3D view, and I wanna extrude that 12 inches. So I'm gonna go to the extrude, so I can go and pick extrude here from the toolbars, extrude, and now I want to select a geometry, and this time I wanna extrude section 2, so I can come here and apply section 2 in the detail view of the extrude. Now, I have the option to add material or add frozen. If I do add frozen, I'm gonna create 2 bodies and 2 parts. We really do not do that, do not need that. We did that when I was using beams because I wanted to define different sections. But here I can continue with add material. So I can come here and use add material, and we want to make sure that we extrude 12 inches. And I'm going to generate, and here comes my second part. If I look at it in the Z, I want to revisit my sketch, 0.17841. Okay, that's the radius, and the other one is 0.29851. Okay, so these are my 2 parts. So now I have 1 part, 1 body that is in 3D. Next, I want to go to Workbench. So I'm gonna double click model. And this is starting mechanical. I see my part here. And if you go to mesh, right click and see generate mesh. It used the default mesh. And if you look here, these are, we call them like tetrahedrons. These are like 4 face, each face has 3 edges. So ANSYS did fit these elements within the 3D CAD model to create this mesh. If I go to static structure, I can put a fixed support on one end. So I'm gonna come here, put a fixed support, and now I'm gonna choose, instead of choosing a vertex, I'm gonna choose the face. So I pick the face, apply, and I put this face is fixed. I wanna go to the other end and apply a displacement. So I'm gonna come here and put a displacement on this face. And this displacement, so this is the face where I wanna put displacement, I'm gonna have only an X component of 0.002. And it is really should not go anywhere in the other 2 directions. But not to over constrain it, I'm gonna simply leave it free. And the force that was applied here was a force of 1,000 pounds applied. Let me just rotate this here. Yes, we want to apply 1,000 pound force on this face. So I'm going to come here and select that face, apply. And I'm selecting this face, and I'm going to put a force, define it using components. And in the X direction, I'm going to put 1,000 Newton. So here is our problem. And please be aware that my part has a structure steel property. When we solved this problem, we did not use structure steel. We use material properties that has 10 million PSI. So this is not what I want. If I want to change the material, I have to come here, go to my engineering data in Workbench, add new material, and I'm going to call it example. And in this example, I'm going to select isotropic elasticity, define the modulus of elasticity, and make sure I fix my units before I do that. This is a common mistake. So I'm going to use US engineering and units. I want to use design values in project units. Here is PSI. Now I'm going to put 1 e to the 7, and I'm going to put 0.3 for Poisson's ratio. So now I've defined that. I'm going to update my project so I can see that in mechanical. When I go to mechanical now, I can define example material property. Now I can check if I can get a solution. So I'm clicking here, solve. And please keep in mind that we have quite a good number of elements. And you see some of the inaccuracy here where I cannot fit a perfect element to capture the contour of my structure. I do have a solution, so I can look at some results. So I'm going to come here and look at results, deformation, and look at total deformation. And let's see how this is going to be deforming. I'm going to solve for that. And you can see this gets a little bit distorted. I think we want to revisit the model and make any fixes that need to be done. But at least for now, I know we're kind of past time. So I'm gonna stop here, and this should allow you to start playing with homework number 9. So please start working on homework number 9. And if you have any questions, please bring them on Thursday. On Thursday, we're going to be doing more on solid elements and using 3D CAD geometry. Okay. Does anyone have any questions before I let you go? All right. Enjoy the rest of the day. Good luck if you're going to the Career Expo today. Please feel free to add ANSYS to your resume. By the end of this class, you should be able to do a few things in ANSYS, and it is a desirable skill to have when you're applying for jobs, right? I'll see you all again on Thursday. Good luck.